Hello friends, my name is Kinjal Bhavsar, lecturer in EC department from VPMP Polytechnic College. Subject name Principle of Electronic Communication. Then Introduction to Communication System. Unit name. Then topic is noise. These are the objectives. First of all, what is noise? Then classification of noise. Normally two types of noise, external noise and internal noise. Okay, then signal to noise ratio, noise factor and noise figure. First, what is noise? So noise is a unwanted electrical disturbance which gives rise to audible or visible disturbance in communication system, and it produces error in digital communication. Then noise may be defined as any unwanted form of energy which tends to interface with proper reception and reproduction of wanted signal. That means कि noise is an unwanted signal. Then this is a types of noise. Noise divided into two part, means two types, external noise and internal noise. So in external noise, that means कि it produced due to the external factor. So three types: atmospheric noise, extraterrestrial noise, man-made noise, otherwise industrial noise. Then internal noise, that means कि it produced due to the internal factor. So internal noise, three part: thermal noise, then sound noise, transit time noise, and at last miscellaneous internal noise. So explain detailing about these types. So first, external noise, otherwise natural noise. So external noise, otherwise natural noise, that means कि noise whose source are external to receiver come under the heading of external noise. So external noise, that means कि it produced due to the external factor. So types are atmospheric noise, extraterrestrial noise, or man-made or industrial noise. So first, atmospheric noise. So atmospheric noise that produced due to the natural phenomena, okay, like rise to noise are electronic storms, solar flames, and radiation in space. That means कि atmospheric noise is produced due to this atmospheric effect. Then in atmospheric noise, noise received by the receiving antenna, okay, from natural source can only be reduced by adjusting, otherwise repositioning the antenna. Okay, तो एटमोस्फेरिक नॉइज रिड्यूस कई रीते थाय टू एडजस्ट एंटेना रिसीविंग एंटेना, अदरवाइज रिपोजिशनिंग द एंटेना. Then extraterrestrial noise second. So this noise originate, otherwise produced from sun and other space. Okay, other space is known as a extraterrestrial noise. So solar noise. So solar noise is produced due to the sun. That means कि our sun being a large body at very high temperature, okay, it radiates lots of noise. Then noise radiation from sun varies with temperature changes on its surface. Okay, સનનું ટેમ્પરેચર ચેન્જ થાય સૂર્યનું, તો એ પ્રમાણે નોઇઝ ચેન્જ થાય છે. Then second is a solar cycles. So what is a solar cycle? So solar cycle, that means कि temperature changes follows a cycle of 11 years, the period of great electrical disturbance, okay, and it repeat often every 11 years. Then cosmic noise. So cosmic noise, that means कि black body noise. So black body noise, otherwise cosmic noise, come from the stars. Then this noise is called as a black body noise, and it is distributed uniformly over entire sky. Then other sources of this noise are galaxy, quasars, pulsars, etc. Okay, then third is a man-made or industrial noise. So man-made noise or industrial noise is the electrical noise produced by sources like automobiles and aircraft ignition, electrical motors, switch gates, then leakage from high voltage line, fluorescent light, then heavy electrical machine. These are the sources produce man-made or industrial noise. Then second part is internal noise, otherwise fundamental noise. So internal noise, that means कि is produced due to the internal factor. So fundamental sources of noise are within the electronics equipment. Then this noise created by any of active or passive device found in receiver. Active or passive device, that means कि active or passive component like passive component resistor, capacitor, inductor. Then active component, as a active component transistor, diode, etc. Then it can be eliminated, otherwise removed, by properly designing the electronic circuits and equipment. Then first is the thermal noise, otherwise Johnson noise. Then this noise generated in any resistance due to the random motion of electrons is called thermal noise, otherwise white noise, otherwise Johnson noise. Then we analyze the thermal noise. It's based in kinetic theory. Then noise power is also proportional to bandwidth over which is measured. Then therefore noise power Pn is proportional to T and B. T, that means ki absolute temperature, and B, that means ki bandwidth. Then proportionality constant is K. Then this proportionality constant K is known as a Boltzmann constant. And Pn is a maximum noise power of output of resistor. This is the thermal noise. Then second is a soot noise. The soot noise is produced due to the random variation in arrival of electron or holes at the output or electron of amplifying device. Then it is appear as a randomly varying noise current superimposed on output. Then the soot noise has a uniform spectral density like thermal noise. Then for soot noise, this formula can be obtained by diode. Then third is a high frequency or transit time noise. So first of all, this type of noise occur in transistor. Then what is a transit time? Transit time is a duration of time that it takes for a current carrier, that means ki holes and electrons, so like holes or current, to move from input to output. This is called transit time. Then at low frequency, this time is negligible. But when frequency of operation is high, then the signal being proceed in the magnitude as a transit time, then the problem can occur. Then transit time show up as a kind of random noise within a device, and this is directly proportional to frequency of operation. Then miscellaneous noise. So in miscellaneous noise, flicker noise. So what is a flicker noise? Flicker noise, otherwise modulation noise, is one appearing in transistor operating at low audio frequencies. That means कि flicker noise produced due to the low audio frequency. Then flicker noise is proportional to emitter current and junction temperature. Then this noise is inversely proportional to frequency. Then it will appear at low frequency below a few kilohertz, and this will produce a fluctuating voltage drop when a direct current flow through device. Then partition noise. So what is partition noise? Partition noise occurs whenever current has to divide between two or more paths and result from a random fluctuation in the division. then it is generated due to random fluctuation in the division of current. Then partition noise is in a transistor will be higher than that in a diode. Then next topic, signal to noise ratio, that means ki SNR. It is defined as ratio of signal power to noise power at same point. Then SNR is equal to S divided by N, that means ki signal power divided by noise power. Then SNR is normally expressed in dB, that means ki decibel. Then this is normally defined in terms of voltage and in terms of power. If the higher value of SNR ratio, then better the system performance in presence of noise. Then next is a noise factor. So what is noise factor? Noise factor is a ratio of signal to noise at input to signal to noise at output of system. That means ki F is equal to S by N ratio at input side divided by S by N ratio at output side. Then ideal value of noise factor is unity. Then noise figure. When noise factor F is expressed in decibel, then it is called noise figure. That means ki noise figure is equal to F is in a dB. dB, that means ki decibel. So 10 log 10 base F. The ideal value of noise figure is 0 dB. Thank you.